if we're asked to graph y equals 3 times the sine of 2x, finding the amplitude, the period, and all the shifts first. If you go back and you consult from last time our notes, and you look at what the amplitude is, it's the absolute value of a, and a is the value that is located immediately in front of the function. Okay, it's the part that's multiplied onto the front of the function. So in this case, that value would be 3. We're taking the absolute value of 3, obviously. We're getting 3 back. So if I see the absolute value of a sitting there, that tells me that's the amplitude idea. And we'll mark that off here on the graph here in just a second. The period. Okay, with the period, what we do is we take, again, going back to the notes from last time, we take the 2 pi and we divide by what is known as the k value. The k value is the part that is immediately in front of the x. So in this case, value in front of the x is 2. Our period is going to be pi. Now what that represents the horizontal length of this graph in one period, okay, in one cycle. Now as we're doing this, it's helpful in terms of the calculations to include this. I usually take the period at this point, whatever I get, and underneath it, I multiply it by 1/4. So 1/4 times pi, which would be pi over 1, get pi over 4 back. The reason I do that is when you consider the graph we came up with last time for sine and cosine, your little segments were each 1/4 the overall distance. So it'll be a little more helpful here in just a moment when we set up all our x values to be tacking on this little 1/4 distance of pi over 4. Okay, next, we're going to find all the shifts. So first shift worth finding would be the horizontal shift. The horizontal shift is also known as the phase shift. The horizontal shift is that little b idea. That little b idea was tacked on to the x part. Usually we had like some parentheses sitting there that showed us, okay, this is the part that's tacked on to x. So if it's added on, if it's subtracted on, rule of thumb to follow is take the opposite sign. Here we don't see any set of parentheses, so basically my horizontal shift is going to be 0. I don't know why I put HA, it should be HS. I'm thinking asymptotes here, aren't I? That's going back a little too far. So horizontal shift is 0. Vertical shift. How much this graph could move up or down. That's determined by a value that is added on to the function. So normally you're going to see it in front of the function somewhere. It's not the 3 value that we see because that came with the amplitude part of this. So the vertical shift, since nothing's added on, that's going to be 0.
Wait, how do you know that the horizontal shift is 0 again?
Horizontal shift, basically you're looking to see if anything is added on to this x right here or subtracted away from that x right there. If you see essentially parentheses and something going on inside those parentheses, that'll give you that horizontal shift value. Okay? So we got all the ingredients to graph. We set up the graph. Kind of like I did on Friday. This graph, the majority of it's going to be on the positive side of the x-axis. So I'll make that side with the x-axis, that positive side, a little bit longer. If I start marking off some key points, say I start with the amplitude value. Since the amplitude was 3, what I want to mark on the y-axis is that value of 3 and its opposite. In a moment here when we sketch this out, we're going to understand that this graph is going to go no higher than 3 and no lower than -3. Okay, once I take care of the amplitude value, moving on to the horizontal shift usually makes sense. If I mark off the horizontal shift, which is at 0, basically I'll be starting there at the origin since this is a sine graph, but we'll fill that part in here after we get all the other values. Okay, once I know where this graph is starting, go back and think about the graph that we came up with last time, or take a look at it. There were 5 key points that we had to find. We've got one of the key points here at 0. Basically, this is going to get spread out now amongst 4 other points we got to find. So I'll mark those places. And to get those values, if I take where I start at 0, I'm going to add on this little pi over 4 value that I found. So I take where I start at 0, I add on pi over 4. And kind of like we did when we were navigating the unit circle, if you want to take the pi's out, do the calculations, then put the pi's back in, that's fine. So I'm taking 0, I'm adding on 1/4. Obviously, I'm getting 1/4 back, right? So I'm putting pi over 4, if I put the pi back in, at the next spot. Where I'm at right now with that pi over 4, if I'm thinking 1/4, I'm going to add on 1/4 again. So add on this same distance again. If I do that, I get 2/4, but I reduce. If I reduce, I get 1/2. So that would be pi over 2 if I put the pi back in. So 1/2 was 2/4, right? So I'm adding on this 1/4 value again. 2/4 plus 1/4 is 3/4. Put the pi back in. And then if you add to 3/4 that 1/4, we're going to get 4/4, right? Which is just 1. If I put the pi back in, it's 1 pi. So really the only value I haven't considered over here out of all the stuff I had to find to start with was the period itself. What you could do to check yourself and make sure that these x values are correct is take this last value here of pi, subtract this first value here of 0, and see if you get the period back. So take where you end, subtract where you begin, see if you get the period back. Obviously here we do. And this graph does not move up or down, right? There was no vertical shift either. So in terms of the vertical shift, we've taken care of the amplitude already on the y-axis. We're set to go. Now another thing I haven't even considered at this point. I really haven't talked about the kind of curve that we have here with sine. See, it really doesn't matter with sine or cosine in terms of our process that we're going to follow to get started. Our process is going to be the same every single time. What I just did here, I do for a cosine graph as well. But now that I've found all the stuff that I need, let's go back to this sine idea and let's consider what the sine graph looks like. Going back to the notes from last time, sine graph is going to start on the x-axis at the point that you first plotted on the x-axis. So we start at the origin. Then 1/4 the way through, you noticed how it was up at its highest point. So here, its highest point is going to be at 3. Halfway through the cycle here, or the period as we call it, it was hitting that x-axis again. 3/4 the way through, it was bottoming out. And then it finished back at the same level where it started. That was the sine graph. And then we fill in the curve because we got our key points to work with. And you've now sketched y equals 3 times the sine of 2x. Might be clear as mud right now, but that's all right. We'll go through a couple more examples. And what's nice, since we did all this legwork last time, is we've come up with the general shape for the curve. We've come up with the patterns that it follows, all the key stuff that you need to find, so that we actually don't have to go through transformations here to get the end result. Okay, we've already applied the transformations. So let's try another. Try a cosine graph. Add a little bit more to this one. Let's take y equals 4 cosine of 3x minus pi over 2. Now, before you go through and do any of these problems, make sure if you see a set of parentheses that contains your x value over here, if you see a number sitting in front of that x that is not a 1, take that number out. Factor it out. Make this y equals 4 cosine of 3 is factored out. Got parentheses here, x minus. Now we've taken a 3 out, trying to figure out what's left. Easiest thing to do. Got pi over 2 in the first place. It's now going to be pi over 6. Easiest thing to do to remember that is just take the number that you factored out, this 3, multiply it to that denominator here. So 3 times 2 obviously gives me 6 back. Now the reason I'm so paranoid about taking that number out is if you go back and look at that form from last time, what did that form follow? You had an a in front, you had a k that was outside the parentheses, right? And then we had this little minus b idea. So it didn't say anything about having any other number in front of this x other than 1. Now I've got all this, go through, I find the amplitude to start. Find the amplitude, you take the absolute value of the a value. The a value is the number immediately in front of the trig function. So in front of cosine we got 4, we're taking the absolute value of 4. Obviously we're getting 4 back. Now last time on the previous example we went through and we found all the information first and then we plotted it, right? How about we plot information as we go here? Because I know all that information we have to find. There's a lot going on there. So if we plot as we go, hopefully that'll simplify the process a little bit. Got an amplitude of 4. So if I mark off 4 on the y-axis, you're marking off 4 and its opposite. We move on to the next part that we have to find. Next part we have to find is the period. So the period is going to be 2 pi divided by the k value. K value is that number that's in front of x. So really looking at the original form or our new and improved form, that k value is going to be 3. Can't reduce that anymore, so period's 2 pi over 3. As I did on the last one, it's a good habit to get into. Go ahead and take 1/4 of that distance. That number we will use then to help us calculate all of our x values along the x-axis. If you multiply that out, you're going to have 2 pi over 12. 2/12 reduces to 1/6, so we make that pi over 6. As far as marking things off at this point, there's not much we can do because we still need a place to start. Okay, we can't really use that pi over 6 yet because we don't know where we're starting. So let's go to where we're starting. Let's look at the horizontal shift on this one. All right, following the form from last time, horizontal shift. That's that b idea. So you look inside the parentheses. You look to see that something's added or subtracted onto the x value. In this case, subtracted onto the x value, we have a pi over 6. We take the opposite. We take pi over 6. Because notice in the form it was minus b. The actual value we wanted, though, was just b itself. So we change the sign. And with the vertical shift, for the vertical shift, there is nothing added onto the function, right? So vertical shift is 0. Now if we mark off some of these values we just found, vertical shift, graph's not going up or down, so don't have to worry about that so much. But the pi over 6 is where we're starting this graph. I'll put that on the x-axis. And like I said on the last one, there's 5 values altogether that you have to find on the x-axis. We've got the first one. The next 4 are going to be equal distances apart. And that distance that they are apart, that 1/4 distance, is this pi over 6 that we found right here. It just so happens the horizontal shift and this 1/4 distance are the same. Just a coincidence. So let's find these other x values now, starting at pi over 6. If you take the pi out of it, we're thinking 1/6. We are adding on to 1/6 this 1/6 distance. So 1/6 and 1/6 is 2/6. That reduces to 1/3, right? That'd be pi over 3 if I put the pi back in. So that was 2/6 reduced to 1/3. At this 2/6, we will now add on again the 1/6. Adding on the 1/6, we get 3/6 now, right? That reduces to 1/2. So pi over 2 if I put the pi back in. That was 3/6. So now we add on 1/6, we get 4/6, right? Reduce that to 2/3. 2 pi over 3. And if we add on another 6, we were at 4/6. Add on another 6, you're at 5/6. So we've got 5 pi over 6. And how we can check these. Take where you just ended, the 5 pi over 6, subtract where you started. If you take where you ended, subtract where you started, you've got 5/6 minus the 6, that's 4/6, right? Or 2/3. Go back to the period now. What's the period? It's 2 pi over 3. So we know we did that correctly. We spaced this out the right way. In terms of filling in the graph now, the fun part, right? We've done all this hard work. Okay, let's add in the curve. You go back, we're graphing a cosine function. So I'm following the same procedure whether it's cosine or sine. But for a cosine graph, if you go back, look at the curve for a cosine graph. That graph started even with, well, basically here it'd be our pi over 6 value. That's where we're starting the cycle of this graph, the period of this graph. And it also started up with the amplitude value. So at pi over 6 and 4, we plot a point. 1/4 the way through, that graph hit the x-axis, right? It created an intercept. Halfway through, that graph sort of bottomed out. So that point there will be even with that bottom value of -4. Then it came back up as an x-intercept. And then it finished back at the same level where we started. So you got to make sure you've got a point included for each of these key x values that you're finding here. If you fill in the curve, get kind of this U-shaped looking thing. There's your cosine graph, complete with all the transformations intact. No extra steps beyond that you got to follow. Thank goodness, right? So if we add a vertical shift, actually let me add a couple of things here. Vertical shift on this one, let's keep it pretty low. Let's just make it 1. 1 minus the sine of 2 times quantity x plus pi over 4. This would be a good problem to do because it covers a lot of different variations of this topic we're talking about. As we followed so far, we'll start with the amplitude. Taking the absolute value of a being the number that's immediately in front of the function. Okay, number immediately in front of the function is -1. So we're taking the absolute value of -1 here. Amplitude is going to be 1. What's important to also appreciate about that negative sitting in front of the function is that negative, like we've done before with transformations, that does flip the graph. So the sine curve is going to turn over here. If we mark that off, setting up our graph over here, 1 and -1, right? That's normally going to be the place where we're starting here. I say normally because this one actually has a vertical shift, right? We'll get to that here in a minute. Let's find the period first. Period is 2 pi over k. K is the number that is immediately in front of the x, or I'm sorry, just in general in front of the x. that quantity that contains the x. So it'd be 2. Period is going to be pi. And the habit we're following here is we're taking 1/4 of that period. So 1/4 pi being pi over 4. That pi over 4 is that magic little distance we need to add on to where we start and keep adding on all the way through. Next was horizontal shift. With the horizontal shift, got to look at the stuff inside the parentheses, right? Whatever's added on or subtracted from the x. Take the opposite sign. So as we see a plus pi over 4, we're going to subtract pi over 4. It's going to be a negative pi over 4. That's where we start. And these negatives can be tricky because you pass over the y-axis a lot on these problems when you're starting on the negative side. So in terms of marking that one off just yet, I might hold off until I'm ready to really tackle all the x values at once. Let's go ahead and look at the vertical shift. Vertical shift, how much the graph moves up or down, determined by a value that's added or subtracted to the front. We've got a 1 that's added on, right? It's a positive 1. So our vertical shift here is going to be 1. We haven't had to worry about this too much yet. But now we've actually got some movement to this graph. What I would do to keep things simple here is I would note that my x-axis, which is normally going to be where y is 0, I'm going to change its value here. I'm going to change its value to 1 because we're moving up 1. Now, if we're moving that up 1, what's that going to do to my original amplitude values here that I used? There you go. We're adding 1 onto those. So negative 1, we add 1, get 0. Positive 1, we add 1, we get 2. So we've adjusted for the vertical shift. We don't have to worry about that later on. Now let's start finding these x values. We know we're starting at negative pi over 4. All right, as we mark this off, starting at negative pi over 4, thinking about how we add on to get to the next value, we're going to add on pi over 4, right? We got to go back to this guy, use that. So you're starting at negative 1/4 if you take the pi out. You're adding on 1/4 if you take the pi out. You're getting 0, right? So our next little marking is going to be here at 0. If I know my next marking is going to be there at 0 and I start to space out the rest of this, we've got 3 more markings we got to find, right? Because there's 5 total. So currently we're at 0. We add on 1/4 to 0. We get 1/4. Put the pi back in, pi over 4. Add on 1/4 to that. You've got 2/4, reduces to 1/2. Add on 1/4 to that. You've got 3/4, or 3 pi over 4. So it appears we've got everything we need, right? Because we've taken care of the vertical shift already. Go back to the kind of graph we're dealing with, sine curve. For sine curve, we know we're going to start basically at that horizontal shift point on our so-called axis there. And then normally, 1/4 the way through, we're going to top out at whatever that little amplitude value was, right? But we got this negative in front that I told you we got to be aware of. That negative does flip the graph. So instead of going up 1/4 the way through, we're going to go down. So 1/4 the way through, we're at 0. We're going to be down here at 0 because of the shift. We're going to come back up, hit the graph. 3/4 the way through, usually you're bottoming out. Now you're going to be up here. You get to the end, you're back at the same level as what you started with. If you fill in your graph, got an upside down sine curve.